These are all my notes on.
All right, here we go, guys. We are going to do cross sections now, and I know you guys are super excited about that. We're going to start on page 16 of the packet for Unit 8. We're going to start with number 7. So this is number 7 on page 16. Okay, it says that region R is bound by the graphs of y equals the square root of x, x equals 0, y equals 0, and x equals 9. So if we're drawing this real quick, we know that we are bound by, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to be 9. So we're going, and then 1, 2, 3, 4. 2, 4, 6, 8, 9. All right, that first line, y equals the square root of x, we know is going to go through 0, 0, 1, 1, 4, 2, and 9, 3. So we're looking at that square root curve that looks like that. And then the line x equals 0 and y equals 0, we know are the x and y axis. And we know that that line, x equals 9, is the vertical line here. So we're basically talking about this shape right here. Now, part A says find the value of A in the interval from 0 to 9 such that the line x equals A divides R into two equal areas. So it's asking us to find a line in this curve where if I were to draw that line, it would cut the area exactly in half. And we don't know whether that line is here. We don't know whether it's here, here. And that's what we've got to figure out. We've got to figure out at what value A is this area equal to that area. All right, so what I want to do is I want to find the whole area first. If I can find the whole area, then I can set the integral equal to half of it and figure out that point, okay? So I'm going to find the whole area. And I know that in order to find the whole area, I do top function, which is y equals the square root of x, minus bottom function, which is y equals 0. And I'm going to set that integral up from 0 to 9 because that's where I'm bound by. So I'm going to do my integral from 0 to 9. And I'm going to do top function, which is the square root of x, minus the bottom function, which is 0, so I'm good to go there. So I'm just going to do the integral from 0 to 9 to the square root of x, dx. All right, so when I integrate that, I know that the square root of x is the same thing as saying x to the 1/2, and I know how to integrate that. I add 1 and then divide by the new exponent, so 1/2 plus 1 is 3/2, so that makes it 2/3 x to the 3/2 from 0 to 9. I'm going to plug in 9. I'm going to use my calculator to do that because I have a calculator and I want to. So I'm going to plug in 9, and 2/3 times 9 raised to the 3/2 gives us 18. All right, so we plug in 9 and we get 18. Minus, we plug in 0, we get 0. So we know that this area is 18 units, all right? And we want to know what value A will make this area, will cut this area in half. So we want to know at what value A is the area 9, okay? So we're going to set up an integral, and we're going to set it equal to 9 and solve for that A value. Okay, so I'm going to say 9, because that's half of that area, equals the integral from 0 to A, and I have no idea what A is, of the square root of x dx. All right, so then I'm going to integrate that just like I did before. 9 equals 2/3 x to the 3/2 from 0 to A. All right, and then I'm going to plug in A, and I'm going to get that 9 equals 2/3 A to the 3/2 minus 0, because when you plug in, you get 0. So now all I have to do is I have to solve for that A. In order to solve for A, I'm going to get rid of the 2/3 by multiplying times 3/2 on both sides. So when I multiply times 3/2, I get 27/2 equals A to the 3/2. And then I'm going to raise everything to the 2/3 power because to raise it to the 2/3 power will get rid of that 3/2 power. Those will cancel. So now I get 27 to the 2/3, 27 halves to the 2/3 power equals A. And if I do that in my calculator, 27 halves raised to the 2/3 power gives us 5.6696 equals A. So that is the number. Oh, it's kind of exactly right where I put it. Go me. That is the number right here, A, that cuts this area into 2 equal pieces. All right. So now let's do 7 part B. I'm going to see if I can copy all of this stuff. Let me see if I can copy just some of it. Oh, rats, I can't. Let's see if I can do that. No, I'll just redraw it. All right, so let's do part A, or sorry, part B. Okay, now on your paper, this part of B is cut off, so listen closely when I tell you this. You're trying to find the value of A that divides the shape into 2 equal volumes. So we're going to find A such that R is cut into 2 equal volumes. All right, so again, those functions are the same. Y equals the square root of x, y equals 0, x equals 0, and x equals 9. So again, I'm actually going to draw it like this time so that you can see the volume part of it. And this is going to go 1, 2, 3, and this is going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay, we knew from the last problem that we were at 0, 0, 1, 1, 1, 2, 3, 4, 2, and 9, 3. That was that square root, and then we were bound by that line, x equals 9. All right, and it says that we're rotating around the x-axis, so that's this way. So remember that the first question we ask ourselves is, which way are we rotating? So we're rotating vertically, so we know we're using our x numbers. So we know that this volume function is going to be pi times 0 to 9. And then all we have is big R. And so remember, this is going to end up looking like this. It's going to end up looking like that when it rotates. So big R is going to be our value from here to our line of rotation. That's big R. And we know that big R is going to be given by that curve y equals the square root of x. All right. So we're going to do the square root of x squared. Because remember, volume is equal to pi times the integral of big R squared. And then for the washer method, volume is equal to pi times the integral of big radius squared minus little radius squared. Just as a little review cloud over here. Review cloud. All right. So we're going to do this volume here, and we have pi from 0 to 9. The square root of x squared is just x, so that's going to be pi times 1/2 x squared from 0 to 9. And if we plug in 9 there, we get 81 halves. So that gives us our, what am I doing? What did I do? Ah, I see what I did. Go me. I was looking at my notes. I did it on my notes wrong. Sitting in the car dealership. Yay for me. Okay, so here we get 81 halves pi when we plug in 9. All right. So now that we have 81 halves, we know that this is this full volume. This is the whole thing, the whole volume, okay? So what did that? Technical difficulties, my bad. I think we're back now. So this is the entire volume, and we want to know what value of A will cut this in half. So we're going to do the exact same thing we did before, and we're going to find the value of A that cuts this into two pieces. So that would be 81/4 pi, okay? So we're going to set the volume equal to 81/4 pi. Equals pi from 0 to a of x, all right? So then 81/4 pi equals pi times 1/2 x squared from 0 to a, all right? And then I'm going to change color so you can see where I'm going with this. 81/4 pi equals pi times that. If we plug in a, we get a squared over 2. If we plug in 0, we get 0. All right, I'm going to divide both sides by pi so that those cancel out. And then I have 81/4 equals a squared over 2. I'm going to multiply times 2 on both sides. When I multiply times 2, that becomes 81/2. All right, and then I have that 81/2 equals a squared, and a equals the square root of 81/2. All right, so that is the value of a that cuts this volume into two equal pieces. All right, it is time to do the cross sections. So here we go. I'm actually going to stop the video here for number 7 because I've never done the screen record on the iPad before, and I want to make sure it works before I go all the way through this. So stopping the recording here for number 7, picking up with number 8 on page 16.